Here we're going to formalize the idea of tangent lines and normal lines. Assume that f of x is differentiable at x equals a. The tangent line to the graph of y equals f of x at x equals a is the line through the point a f of a with slope f prime of a, with equation given by y minus f of a equals f prime of a times x minus a. I don't want us to think about this as a new formula. The idea is that the point is some x1, y1, and the slope is m. So this equation is really just y minus y1 equals m times the quantity x minus x1. So it's point-slope form of a line through the point a f of a with slope f prime of a. So here, let's go ahead and take a look at this curve f of x. The point of tangency, we're told, is a f of a, and then the slope of the tangent line m is f prime of a. So that tangent line just sort of grazes the surface of the curve at the point of tangency. Now, the normal line is perpendicular to the tangent line at the point of tangency a f of a. So over here, we can see this normal line also passes through the same point as the tangent line, but is perpendicular, so forms a right angle with that tangent line. And the equation there is given by y minus f of a equals -1 over f prime of a times the quantity x minus a. So the only difference is in the slopes. If our tangent slope is f prime of a, our normal slope is the opposite reciprocal. So the reciprocal 1 over f prime of a, and then opposite sign, this was positive, so we're making it negative. Let's find the tangent line and the normal line to the curve f of x equals 3x squared minus x at x equals 1, then sketch each on the graph of f of x shown. Let's start with the tangent line. We're going to need the point of tangency and the slope of the tangent line. We have the x value of the point of tangency, so to find the y value, we're going to substitute x equals 1 into the original function. So we're going to have f of 1 is equal to 3 times 1 squared minus 1, which is 2. So our point is 1, 2. And then we need the slope of the tangent line. So we need the derivative at x equals 1. We'll go ahead and find the derivative, f prime of x, using the power rule. So here we're going to have 6x minus 1 as our functional derivative. We need the numerical derivative at 1. So f prime of 1 is 6 times 1 minus 1, which is 5. Now I have my point of tangency and my slope, so I can substitute it into point-slope form of a line. So our tangent line is going to be y minus 2 is equal to 5 times the quantity x minus 1. This tangent line is given in point-slope form. If we want to, we can solve for y to get it into slope-intercept form. So we can go ahead and say that this is 5x if we distribute the 5, and then we'll have minus 5, and we'll add 2 to the other side, so 5x minus 3. That's if we want the line in slope-intercept form. So both of these are the same equation, the equation of the tangent line. Now, to find the normal line, I'm just going to change the slope. So to find the normal line, I'm going to still start with y minus 2 is equal to -1/5 times the quantity x minus 1. So we take the tangent slope, we make it the opposite sign, so it was positive, we make it negative, and then we take the reciprocal of the slope, so 5 over 1 becomes 1 over 5. So here is my equation of the normal line given in point-slope form. If we want it in slope-intercept form, again, we have to solve for y. So here, since I'm dealing with fractions, I'll show a little more work. I have -1/5 x plus 1/5 plus 2, which is 10 over 5. So our normal line in slope-intercept form is -1/5 x plus 11 over 5. Now we want to sketch each of these on the graph of f of x shown. So we're going to go to the x value 1, and we can see that that corresponding y value is 2. We solved for it earlier, and it matches with the graph. So my point of tangency is 1, 2. And then we're going to go ahead and sketch our tangent line. So here I've drawn a line that just barely grazes the surface, taps the surface right at that point of tangency. Hopefully we can convince ourselves that it is the line 5x minus 3, so it has a slope up 5 over 1, and then down here it would have a y-intercept of -3. And then the normal line will still pass through this point, but be perpendicular to this tangent line I just drew. So it's going to form a right angle. So here is my normal line. We can see that it passes through about 2 1/5, that's 11 over 5 as a y-intercept, and the slope is going to be -1/5, so I can see that negative slope. Now suppose f of 1 equals 4 and dy dx equals 3x minus x squared. Find an equation of the tangent line to y equals f of x at x equals 1. Anytime we see that we want to find the equation of a tangent line, we want to think about needing both a point and a slope. We need a point and a slope. Now here, we're told that we want the point of tangency to be at the x value 1. And so to find the corresponding y value, ideally we'd want the function y equals f of x to substitute 1 into, but we weren't given the function y equals f of x. But I am given this piece of information here, f of 1 is equal to 4. So when I substitute 1 into f, whatever that function is, I will get out a y value of 4. So my point was given to me, just in different notation. We have the point of tangency 1, 4. Now, I also need the slope of the tangent line at x equals 1. So for that, I want the derivative at x equals 1, and I've actually been given the derivative here, not the original function. So dy dx is the derivative already, so we don't want to take a derivative. We're just going to substitute 1 into dy dx. So the slope is dy dx at x equals 1, which is 3 times 1 minus 1 squared, or 2. So now that I have my point and my slope, I can plug that into point-slope form of a line. Y minus 4 equals 2 times the quantity x minus 1. So here is an equation of the tangent line in point-slope form. If we were asked for slope-intercept form, we would solve for y, so we'd get y equals 2x and then minus 2, but when we add 4 to the other side, it's going to be 2x plus 2. In this next problem, we're given the function f of x equals 2x cubed minus x squared. And in part A, we're asked to find the values of x where the tangent line to f of x is horizontal. Now the graph won't necessarily be given to us, but just to understand the concept, I have the graph here of 2x cubed minus x squared. And we're looking for the values of x where the tangent line is horizontal. So a horizontal line has a slope of 0. I want to find all the x values where the tangent line has a slope of 0. Now, here, I want to go ahead and sketch the locations where that happens. So I can see that at x equals 0, if I draw a tangent line where it just taps the surface, I'm going to have a horizontal line, a line of slope 0. And then I'd also have another one about right here. So somewhere between 0 and 1, there'd be another horizontal tangent line with a slope of 0. So we know we're looking for two x values. We can see that one of those x values, because we have the graph, is 0, but we want to find what that other value is algebraically. So whenever I see the phrase tangent line is horizontal, I want to think that the slope of the tangent line is 0. Now, the slope of the tangent line, that's the derivative. The derivative is the slope of the tangent line. So really what this is asking me to do is to find the derivative and set it equal to 0. The word is means equals. So we're going to set the derivative equal to 0 to find those values of x that we're looking for. Here, to find the derivative, we get to use the power rule, so that's nice. So f prime of x is equal to 6x squared minus 2x. So we want to take that and we want to set that equal to 0. So I'm going to start by factoring it. I'm going to factor out a 2x, and I'm left with 3x minus 1. So let's set the factored version equal to 0, and then set each factor equal to 0. So 2x equals 0, and 3x minus 1 equals 0. Dividing by 2, we get x equals 0. Visually, we kind of already knew that. And then now here, if I add the 1 and divide by 3, I'm going to get x is equal to 1/3. And visually, that does line up. We said it was some value between 0 and 1, so it turns out it is at x equals 1/3. So here, the key takeaway, if I want tangent lines that are horizontal, the slope of the tangent line is 0, and the slope of the tangent line is the derivative. So we have to set the derivative equal to 0. We're still dealing with the same function. In part B, we're being asked to find the values of f of x where the slope of the tangent line is 4. So we can actually just take this ending phrase here and turn it directly into an equation to solve. The slope of the tangent line is the derivative. So this is saying to take the derivative and set it equal is to 4. So we need to solve when does f prime of x equal 4? Well, we already found f prime of x was 6x squared minus 2x. So when does that equal 4? Now, just a quick algebra thing, let's not do something crazy. We are not going to do what we did on the last one and factor a 2x out of the left-hand side, because this is not equal to 0. I have to set a quadratic equal to 0 in order to start factoring it and solving it. So we are going to subtract the 4 to the other side to set it equal to 0. Now, everything here is divisible by 2, so let's divide the 2 out of this whole thing to get 3x squared minus x minus 2 equals 0. And now we'll factor this quadratic. So we know it has to be 3x and x. And so we're looking for these two numbers here to make the middle term work out. And so let's see, we're going to have a 2 and a 1. And let's see, a -1 and a +2 should work out. So minus 3x plus 2x will give us that -x minus 2. So then we set each factor equal to 0. So we'll have x is equal to -2/3 and x is equal to 1. So I did that mental math, subtract 2, divide by 3, add 1. So these are the two x values where the slope of the tangent line will be equal to 4. So we still have that graph of f of x over here. Let's go ahead and go to those x values and draw tangent lines and kind of see what's happening. All right, so over here at -2/3, I went and found the function to find the point of tangency, and I drew a tangent line. And yeah, it looks like that has a pretty steep slope, a slope of 4. And then at x equals 1, I came up to my y value to draw my point of tangency, and that also looks like it has a slope of 4. So these lines are parallel. In this example, we're given the function f of x equals 2e to the x minus 3x. And in part A, we want to find the x values where f prime of x equals 0. So here, we're just flat out told, set the derivative equal to 0, instead of being asked to find the x values where the tangent line is horizontal. But same idea. So let's find the derivative. F prime of x is going to be 2e to the x minus 3 is equal to 0. To solve for x, let's add the 3 and divide by 2, so we get e to the x is equal to 3/2. And then to solve for x, we need to take the natural log of both sides. So if we take natural log of e to the x and natural log of 3/2, natural log of e to the x is just x, so x is the natural log of 3/2. Now for part B, using the same function, write an equation of the tangent line to f of x at x equals 0 in slope-intercept form. So remember, if we want an equation of a tangent line, we need a point and a slope. Now we have the x value of the point, we have x equals 0. To find the y value of the point, I plug 0 into the original function. So I have 0, comma, and then I'm missing a value. To find it, let's plug 0 into f of x, 2e to the 0 minus 3 times 0. So that's just 2. E to the 0 is 1. So my point is 0, 2. And my slope is going to be found by substituting 0 into the derivative. The slope is f prime of 0. Well, we already found f prime of x was 2e to the x minus 3. So f prime of 0, well, that's 2e to the 0 minus 3. That's 2 minus 3, or negative 1. So we have our point, our x1, y1, our slope, our m. So plugging this into point slope form of a line, we'll have y minus 2 equals negative 1 times x minus 0. That's in point slope form. To get to slope intercept form, we'll solve for y. So we'll have y is equal to negative x and then plus 2 if we add the 2 to the other side. In this example, we're going to take it up a notch in difficulty. We want to find an equation of the tangent line to f of x equals the square root of x that is parallel to the line 2x minus y equals 1. Let's focus on the fact that we want an equation of a tangent line, so we know we need two things. We need a point and we need a slope. Now, unfortunately, we haven't been directly given either of those in the problem statement. We are told that our tangent line has to be parallel to the line 2x minus y equals 1. Now, parallel lines have the same slope. So if I can find the slope of this line, then I know the slope of my tangent line. Well, I have to write this in slope-intercept form to identify the slope. So I'm going to solve this for y. So here I'm going to have negative y is equal to 1 minus 2x, and then we'll divide by the negative. So y is equal to 2x minus 1. So the slope of this line is 2, and I'm told my tangent line has to be parallel to this line. So that means that the slope of my tangent line is 2. But I still don't have a point. I'm missing an a and the f of a value. So let's dig deeper. What do we know about this slope 2? Well, the slope 2 must equal the derivative of f at that a value. So 2 must equal f prime of a. This is an equation that I can use to solve for a. I just need to be able to find f prime of x and then plug a into it and set it equal to 2. So let's come back over here and find f prime of x. So here f of x is equal to x to the 1/2. F prime of x is equal to 1/2 x to the negative 1/2, or 1 over 2 times the square root of x. This is a derivative we want to be able to jump straight to. It comes up pretty often, 1 over 2 rad x. So I want to solve f prime of a is equal to 2. So let's substitute a into f prime of x. 1 over 2 radical a must be equal to 2. This is an equation that I can solve for a. Let's multiply 2 radical a to the other side. So 1 is equal to 4 times radical a. Let's divide by 4. So 1/4 is equal to the square root of a. Now to get a by itself, I'll have to square both sides. So I'll have 1/4 squared, that's 1/16, is equal to a. So from here, again, we are squaring both sides. So we found a. A is equal to 1/16. And so I'm going to go ahead and come over here and substitute in 1/16 for a. And then how do I find the corresponding y value? I plug a into the original function. So f of 1/16, the square root of 1 over 16, is 1 over 4. So we have our point. So not too bad, not too bad. Now we just substitute our point and slope into point slope form. So y minus 1/4 is equal to 2 times the quantity x minus 1 over 16. And we were not told to leave it in a specific form, so we'll go ahead and leave it in point slope form. Before moving on, let's look at the graphs to make sure we understand what we just did. We have the square root of x function here, and we wanted an equation of the tangent line that was parallel to y equals 2x minus 1. Now the point of tangency we found was 1/16, 1/4, so we're pretty close to 0, 0, and that checks out with our rough sketch here. If I get pretty close to 0, 0 at 1/16, 1/4, and I draw a tangent line, it's going to have approximately, in my picture, the same slope as my line y equals 2x minus 1. On this problem, we want to find a parabola with equation f of x equals ax squared plus bx plus c that has tangent slope 4 at x equals 1, tangent slope 8 at x equals -1, and passes through the point 2, 15. So we're in search of the missing values in the parabola, a, b, and c, and we're given 3 pieces of information. Let's break them down. We're told that our function has tangent slope 4 at x equals 1. So that means that f prime of 1 is equal to 4. We're told that our function has tangent slope 8 at x equals 1. So that means that f prime of -1 is equal to 8. And we're told that this passes through the point 2, 15. So this is not about derivatives. This is simply telling us that f of 2 is equal to 15. Now we're going to use these 3 pieces of information to find our 3 missing values of a, b, and c. First, let's go ahead and find the derivative of f of x. So f prime of x is 2ax plus b. And now we know that f prime of 1 is equal to 4. So when I substitute 1 into this x, that's going to equal 4. So what I'm going to do here is I'm going to say I'm substituting 1 into x to get out 4. So 2a plus b is equal to 4. And then when I substitute in -1, so f prime of -1, that's going to give me a positive 8. So let's see, if I let x be -1, then I'm going to have -2a plus b is equal to 8. Notice what I've just created here. I've created a system of equations using my 2 derivative pieces of information. Now I can solve this system to find a and b. This is set up nicely to use the elimination or addition method. If I just add these 2 equations together, 2a minus 2a is going to cancel. So I'm just going to end up with 2b is equal to 12 if I add down. So b is equal to 6. And then I can substitute b equals 6 into either of these 2 equations. So I'll substitute it into the top one here. So we'll say 2a plus 6 is equal to 4. Or 2a is equal to -2 if I subtract the 6 and divide by 2, I'll get a is equal to -1. So I have a is -1 and b is 6. All I'm missing is the value of c, and I still haven't used f of 2 is equal to 15. Well, let's plug in what we know for f of x. F of x is -x squared plus 6x, and we still need to find that value of c. Well, when I substitute 2 into this equation into x, that must output 15. So let's use that to solve for c. So 15 is going to be the output when I substitute in 2 for x. So now all that's left is to solve for this value of c. And so I'm going to have 15 is equal to -4 plus 12 plus c. -4 plus 12 is 8, and subtracting 8 from 15, I'm going to get 7. So c is equal to 7, leaving my final answer for f of x to be the quadratic -x squared plus 6x plus 7.